Skeletal system made up of, sorry about that, bones, joints, ligaments, and cartilage. Now, the interesting thing about this is a lot of people think a joint is actually a thing, but if you really think about it, fabulous drawing ability being shown here, a joint is simply where two bones come together. It's a joint. Those bones are held together by ligaments, and in the middle is cartilage to cushion it. Why do we have a skeletal system? Well, there are 5 things a skeletal system does for you. There we are. There's a human skeleton. It provides for your muscles to attach and to help you move. We'll take a look at this in class with our skeleton, but muscles attach to these bones, and where they attach, they help the bone move. So, for example, if you take your jaw muscle, you have a muscle attachment up here, down here to your mandible to help that mandible close. Okay, you have a muscle from here over to your biceps to help pull your arm in, your pectoral muscle. Okay, you have quadriceps muscles on your legs that attach down here and there and help pull your leg up. Shape and structure. What you look like is pretty much determined by your skeleton. Okay, how tall you are, how wide you are, how long your fingers are, the structure of your face and cheekbones. Protect. Okay, your brain is protected by this big, thick skull. Your heart and lungs are protected by your rib cage. Reproductive organs are protected by your pelvis, and so on. One function that the skeleton has that you may not have known is that it makes red blood cells. Red blood cells are made in the center of bones, a place called the bone marrow. Talk about that a little more later. The fifth function of the skeleton is to store minerals, especially calcium and phosphorus. Calcium is used in muscle contraction and nerve function. So calcium and phosphorus are stored in your bones. Use calcium for nerve and muscle function. This is why you don't have to eat milk or drink milk constantly, because you store much of the calcium in your skeleton. So let's look at how a bone is put together. And this is kind of very diagrammatic, but when you look at the ends of bone, there are something called spongy bone. They have like this lattice work structure to the bones. So they're kind of like at the end with spaces in there and stuff. The middle of the bone is this very hard, rigid part called compact bone. What a bone has that maybe you don't think of, because when you look at a skeleton or a bone as we pass them around in class, you'll notice that you can't see any holes in it, but there are canals, because your bones, since you need make red blood cells here, they have to get out. Okay, plus if you've ever broken a bone, you know it hurts. So you have to be able to have canals for blood vessels and nerves. And we'll take a look at some bones in class and see that. So how do bones grow? Well, here's a skull of a fetus. Okay, a fetus is a baby that hasn't been born yet, and this one died, and then the skull was taken. And notice, look at the top of the skull here, how these bones haven't yet grown together. And what's left here, better not write in black there, is called the soft spot. And if you've ever held a baby and felt the top of its head, you feel this soft spot on the top of its head. You obviously don't have one anymore. Bones pretty much develop from cartilage. Now, in a skull like this, it's not cartilage, it's a membrane. But in the long bones of your body, they develop from cartilage. The bones in your hands and feet and skull don't fully form until up to 5 years after birth. if you take an x-ray if you look up some x-rays of a baby's hand and feet, they're not, all the bones aren't there like in your hands and feet. Now, why is a baby's skull like this? Well, these bones of the skull are growing towards each other. And where they meet, they'll form these squiggly lines on the top of a skull called sutures. Even though they're not really, suture is another word for like sewing something up. So here is a suture where the bones, this bone and this bone grew together. But when a baby is born, its bones haven't grown together yet. One big reason for that is you have to be able to fit out the birth canal. A 10-centimeter circle you got to get that baby's head out of. So it needs to be a little bit flexible yet. Yes, it's good to be a guy. Yes, it is. And then you have something called the growth plate that fills in after puberty. Now let's talk about that. Here's a bone. Let's say this is the femur bone. On the ends of each bone is an area of cartilage. In most of you, since you're ninth graders, you still have this cartilage at the end of your bone there. And what's happening in you is, as you're growing, this bone is being deposited here and here on each side of that cartilage. And as you put bone down like that, the bone gets longer. Now, the cool thing, and the thing we don't really understand about humans, is that your bones all pretty much grow at the same rate. Otherwise, you'd have one leg shorter than the other, and we'd have to call you Eileen. So all your bones grow at the same rate. They put down bone here, and then until you stop growing. Sometime after puberty, your bones stop growing. And what happens then is this cartilage plate fills in with bone. And we'll look at a couple x-rays in a minute, and we'll show you that. So on this x-ray here, well, we can start with this x-ray. Here's a fractured bone. Okay, and then here's the result afterwards where they put screws in a plate in there. Here's an x-ray where you can see the growth plate. Okay, you see this line here. So a doctor's looking at this x-ray of a knee and tells you, oh, you got some growing to do yet, because your growth plate is visible. Okay, in a person who is adult like me, that would all be white. You wouldn't be able to see it. A brief discussion of how x-rays work. I'm guessing many of you have been x-rayed in your life. Okay, if not by a doctor, by a dentist. You go into the doctor's office or whatever for your x-ray, and they have this plate. It's black. Let's say you're getting your leg x-rayed. And they have like this crosshairs on it, and then you lay on here, and you put your leg across the crosshairs. And then, of course, this always weirded me out a little bit. They'd put this lead stuff on me, and then the lady would always go back in this giant, thick-walled room, and I'd always think, geez, man, what's going to happen? I got my leg on this bullseye, and why are they like running to hide? Is something going to blow up, or we're going to have, well, what happens is they shine x-rays on your leg. Behind this is a film. Now, you guys don't know film very much because all cameras are digital, but it's an x-ray film. And so as the x-rays from the machine pass into your leg, they bounce off of the bone. And they hit the plate where there is no bone, where they go through the skin and hit the plate. So on the plate, the x-rays are black, and where the x-rays don't hit the plate is white. It's a negative. This one down here is an MRI. We're not going to get into the details of it, but an MRI enables you to see ligaments in a knee joint. And here's a tendon holding the bone to the bone in the knee joint. And here's a view of a little bit of cartilage in the knee joint. So that's a brief introduction to the skeletal system.